Hey Geometry, in this video we're going to be writing the standard equation of a circle given a graph, and we're going to be graphing a circle given an equation. So to start out, when we're given a graph, we want to identify the radius and the center of the circle. Those values are going to be used to be plugged right into the standard equation for our circle. So to remember, the standard equation of a circle is x minus h squared plus y minus k squared equals r squared. H comma k is the center of our circle. So I'll write that over here. H comma k equals the center, and we know that r stands for radius. All right, so the radius of our circle here, we are starting at the center, and we're moving out 2 spaces. So our radius is 2. So from the center to the edge of the circle. Our center, we have 0, 0. So we haven't moved anywhere for this one. We're at the origin. To plug these values in, so again, this is my h and my k. I'm plugging r, h, and k exactly as they are into this equation. I have x minus 0 squared plus y minus 0 squared equals 2 squared. X minus 0 squared can be rewritten as just x squared, y minus 0 squared just as y squared, and 2 squared we know is 4. Let's do the same thing for number 14. We want to identify the radius and identify the center. I'm going to look for the center first in this one. I'm over here, so I've moved 1, 2, 3 to the left, so negative 3, and then 1, 2, 3 up. Positive 3. From my center to the edge of my circle, I have a radius of 1. So my equation, I plug this in. X minus negative 3. That becomes x plus 3. Squared plus y minus 3 squared equals r squared. R squared is 1, because r is 1, 1 squared is 1. So notice how I have a negative 3, so I have plus 3. I have a positive 3, so I have minus 3. It's going to be our opposite signs. For number 17, we want to always be careful. I'm going to make a little bit of a note. Be careful with scale. And what I mean by scale is how many spaces I'm moving for each block. So in the previous examples, this was a distance of 1, 2, 3, 4. But in number 17, it looks like we're counting by 5s. 5, 10, 15, 20. So instead of having our center be 0, 1, 2, 3, negative 4, our center is actually 0, negative 5, 10, 15, 20, negative 20. And our radius, instead of being 2, is actually 5, 10. Our radius is 10. So from here, we want to write the equation of our circle. So filling in everything exactly as it is into our standard equation, x minus 0 squared, so from the standard equation up here, x minus 0 squared, which is just x squared, plus y minus negative 20, which becomes y plus 20, squared, equals 10 squared, which is 100. Okay, next thing we're going to do is, given an equation, we're going to graph. So in these problems above, we were given a graph, we identified the radius and center, then we wrote the equation. Well, in these problems again, we're going to identify the radius and the center, and then we're going to graph. So looking at number 19, the center, h comma k. We have nothing in our parentheses. So again, I could rewrite this. This is the same thing as x minus 0 squared plus y minus 0 squared is 25. So technically my center is 0, 0. We'll get used to seeing things like this with x squared and y squared and automatically knowing that the center is going to be at the origin. The radius, the square root of 25, is 5. We take the center and we plot it. 0, 0. We take the radius. So from the center, I'm going to go up 5 spaces, to the left 5 spaces, down 5 spaces, and to the right 5 spaces. I now have 4 points around the center of my circle. I'm going to do my best to connect those with curved lines to form this circle. It's not going to be perfect as long as it doesn't look like a box. We don't want to connect them with straight lines. We want to try to connect them with curved lines.